Hello, welcome to Mini Rust in Rust video 14. My name's Andy. You might know that if you've been following along. We are writing a little version of Rust, kind of a little version of Rust, it won't work exactly like Rust, in Rust. How are you today? I'm actually quite sad for reasons I won't go into, but don't worry, my life is like this beautiful dream. Sometimes feeling sad is a thing that happens. And if you're feeling sad today, then I just send you a little bit of love. That's meaningless, or I don't know, not. Anyway, we have for ages now been working towards making this test pass. So essentially being able to give a little bit of program to our evaluator. Oh, look, we can make this a bit less weird now. We can get rid of that space there because we fixed our Lexer so that it worked. We've been working towards getting this little bit of code to actually run and do what it says it does. So set the value x to 3, add 4 to it, and give us back the answer. And the answer should be a 7. And I don't know if we're going to do it this video or not, but we're so much closer than we've been for ages. So we've managed to get all the lexing and parsing needed to make this stuff work. And we're going to start at least on the process of making our evaluator capable of understanding variables and adding things to them. And we'll see how far we get. So let's unignore our test and run it. And we should see that it fails pretty rapidly. I'm hoping it's going to fail in the place I'm expecting it to fail, which is where we have a to-do. On line 40. That looks right. So for line 43, line 42. Anyway, either way, the missing bit of our evaluator code is that we haven't done anything with assignments, and also this is also a statement as well as an assignment, right? Because it has a semicolon at the end of it. So between these two, we haven't handled them yet. But I want to just quickly recap for you how this evaluator works. So what's the shape of it? So basically, there's a function called eval, which takes in the reference of the file that we're working on, so that we can give good error messages. But the real thing that it operates on is this trees thing, which is an iterator of syntax trees. And syntax trees are basically parsed bits of code. So bits of code that have been made into that tree structure of values that are kind of in the right logical shape, but they're not really understood. And then the evaluator's job is to understand them and run them. So all this eval function does is returns you back as this thing called a values, which is an iterator. And then we implement iterator on it here. No. Somewhere. We implement iterator further down, I guess. Yeah, implement iterator for values. But all that does is calls eval next. And eval next does the real work. And most of the work actually happens inside eval tree. So when we've got a single syntax tree, you want to evaluate it. So in our case, we've got, say that, well, if we gave in like x plus 4 as this syntax tree, then we want it to return back 7 eventually, because we know that x is 3 in our example. Anyway, so eval tree is where all the magic happens, and we've left a couple of to-dos in here because we hadn't yet got around to figuring out how assignments work and how statements work. Now, I'm kind of thinking, could be wrong, but I'm thinking that for a statement, we probably don't want to do anything at all, because, which we can't do like that. We have to give back some kind of nothing value or something, I guess. What are we going to do here? Let's try and see what values we have available to us. So I guess we're going to need a new type of value called unit, which means we're not returning anything. So it's not like a none in Python or a null in Java. It's like It's more like a void in C or Java, but it's not in the type system. This is like a value that a value that we're using inside our interpreter to represent the fact that we're not returning a value in the programming language. I mean, if that all sounds very esoteric, don't worry about it. We're going to make ourselves a new enum value. So basically, at the moment, we only know how to deal with I32s, and now this new thing called unit. And that's a slightly confusing name, I guess. But I'm pretty sure that's what the Rust community call bracket bracket. Pretty sure, unless I'm getting confused. So if we do absolutely nothing when we encounter a statement, then I hope we'll get... Oh, okay, hold on. We haven't finished dealing with this yet. Because that enum variant is now going to be used in some places that we haven't handled. So... all right, yeah, this match statement, right, okay, it was confusing me because there's two of them here. But this match statement now has to deal with all kinds of different things, like a unit on one side or a unit on both sides or whatever. So this is making me think, is unit wrong? Should values not... Should it be that instead of that we return an option of value from that evaluator function instead of... Now we've got a deal. If a value can be this kind of weird null value called unit, then everywhere we deal with a value, we've got to deal with the fact that it might be something that can never happen, right? Which is an empty value. So that sounds wrong. It seems wrong. So we're going back. We're changing our mind. We're not going to have unit be something you can have in a value, which I guess means we're going to need to be able to return a none from here. And I guess that means that these other functions that we call are going to have to return options unless we wrap them in a sort of option at this point. Maybe that's right. So if leaf is always going to return a value, I think it is. Let's imagine for a second it is. There's probably not a function already written for us that can wrap up this value in an option. So I think we're going to have to do something like this. And then if we did the same thing here, maybe we need a function to do this for us. Maybe we'll get away with that. That looks right, but now that we've changed the return type of this function, so we're going to have to do something there. And I guess it is that this is also an option value. And now we've got somewhere else complaining at us. Right, and we get back to this same problem, which is that eval tree now might return something that is missing, and we're back into the same thing that an operator expects non-missing things to come back. So we've got some kind of fundamental problem here. That our evaluator is not in any way kind of protecting itself using the type system from empty values appearing. I wonder whether we can get away with this by allowing statements in some sense to return the value they just evaluated, but then it's not actually used for anything. So I might have been making all of this a lot harder than it needed to be. So let's try that idea out, and then if that doesn't work, then you know that this stream this video has really not gone to plan. So let's just say, if we find a statement, then the result of evaluating that statement is maybe the statement itself. Is that even a value? No. It's just a syntax tree, yeah. Well, let's get ourselves past this roadblock by just letting it be like some useless value. And now this means we're going to have to come back to this because that's clearly not correct, right? So let's give ourselves a to-do here. Statements should not return 0. And maybe we'll find that later, when that match that we were looking at before will actually change its structure anyway, because there's going to be a lot more different types of value than just I32. So that particular way of handling the left-hand side and the right-hand side of an operator might not make sense anyway. So this might become a non-problem. Maybe we should have a unit type of value to handle this, or maybe something else will fall out. What we're going to do right now is not worry about it, because I'm pretty sure, that as we're iterating through, we get one tree at a time, and we return it back. So whoever's iterating through these trees can just throw away every statement that comes back to them. But then maybe they won't know to do that. All right, we might have more work to do here, but that wasn't our goal for today, to think about how statements really work and what statements really are in some meaningful sense. Our goal was to get this assignment operator to actually work. So if I do that and just return 0, then we get it complaining that on line 63 we have a to-do. So what's on line 63? Okay, all right, so we've got to a situation where there's a symbol in our code. It's the first time we've evaluated any code with a symbol in it. I guess that would make sense, because how can you have a symbol without an assignment statement to put some value into it? Okay, so we need to figure out what happens when you evaluate a symbol. And I think in order to do that, we're going to need somewhere to look up and find the value of that symbol. And that pushes us towards where I thought we were going to go in this video, which is we're going to make something that I'm going to call an environment, which is a place where all our variables are stored. And it's going to make evaluation look a little bit slightly more complicated, because our values thing, which is this like iterator, so maybe this value should be called like eval values or something like that. It's really just the values is really just the implementation of eval. So that I think is going to have something which we're going to call an environment. I think it's going to be a struct called environment. And I guess I'll put this in its own file. So we're going to make a new one. Like so. But we better make a file for it. And we're not going to think too much about what it's like yet. We're certainly not going to make the full version of how an environment works in this video. We're going to do the absolute minimum that makes our our test pass without being completely done. We probably won't do like return 7, but we'll do something that's very much the simplest possible way of thinking about this thing. So yeah, an environment is a thing that holds your variables, and hopefully it will warn us that we haven't imported it yet. What are we doing with imports? I don't remember. We just, yeah. We're being completely longhand about when we import environment, we're importing it by its kind of full path, which is fine. Okay. Now, are you going to complain at me that there's no new function? Yes, you are. Good. So, for now, let's imagine you can make a new environment by calling new. Let's just double check whether any of our other new functions are pubcreate or anything like that. No. All right, fine. So you can make a new environment. There's nothing in it yet. We're going to figure that out. And what's the use of this environment? Well, it's going to get stored. It's already stored in our values. And yeah, here we're making an empty one, which may or may not be the right thing to do. We may need it passed in. But we'll think about that in a second. Yeah, this might work for our purposes for now. Because this values object sticks around for a little while. So we'll make a new one when we create it and then use it as we go. And we have well, the to-do that we hit was not the one I was expecting, but this one, which is I'm looking up a leaf token, which just means a token that's not like inside, that's not actually an operator or something like that. So I'm looking up a leaf node in our syntax tree, so just like one at the end that's on its own, and I've found a symbol which we'll call S. And in order to evaluate a symbol, what we actually do is just look it up in the environment, something like this, with some kind of get method, which we're going to have to write. But let's have a quick look at what a symbol is. Oh, it's just a string, for now at least. Okay, I'm slightly surprised. I thought it would be cleverer than that. So basically, we're going to look up this symbol in our environment, because our environment is the place where variables get stored. And return it, or possibly return some kind of thing saying it doesn't exist. Now, this is interesting, and I think it probably gets to the point that we were hitting earlier, which is that, again, we're in a situation where you might be returning a kind of null value or nothing value to say that variable doesn't exist. And in that case, and in the previous case, one of the things that was going on there is that our type system ought to have detected this error before it happened. And so it could never actually happen. We would never be looking for the value of a statement, because a statement kind of doesn't give you a value. And we'd never be looking for a variable that doesn't exist, because we would have done some type checking that checks that that variable exists. So the way we can respond to that immediately, I guess, is by saying we can just kind of panic if a variable doesn't exist, because we kind of know that we will have checked it later. So I think that's probably what we'll do. But then we get to the sticky problem that I've never written a type checker in any serious way before. So if we're going to start checking types, which we definitely are going to need to do if we're going to make a Rust-like language, otherwise what on earth are we doing? You might be watching me flailing around, not having any idea how to write that bit of code. So look forward to that. Anyway, we're going to have a get method on environment, and I guess if it returns none, we panic here, or maybe we panic inside. So for now, let's panic inside, because it's kind of neater looking from here. So we're making a get function method rather, and it takes an argument which is going to be I guess we call this symbol. I guess we call this, no, we call this name. Let's say we're looking up a name in an environment. And yeah, the return value is going to be a value. Or there could be an error. I guess we could say that there's an error if this variable doesn't exist in this environment, I guess. So we're not going to implement that yet. And at this point, I'm starting to think we probably need some tests for environment, which will help this feel a little bit less unhinged. So let's write a couple of simple tests for environment, and then that'll give us an excuse to implement environment properly. And then we can just use it in our other code. So what's the right test for an environment? I guess we could say getting a non-existent name is an error. I think that's how we're going to end up here. Although it might not be, it might be a kind of crash, but we'll see. So to do this, we're going to need to make an environment with nothing in it, and then we're going to need to put something in there, which I think we can call set. And let's use a different variable name from the one we're using in our other example. And we're going to set it to, it's going to be a value. And at the moment, the only type of value we have is an I32. So we'll do a value of 68. And then we're going to assert that when you ask for it back out of the environment, you get the same thing. Oh, I'm testing the wrong thing. Never mind. We'll do this. We'll carry on with this. I jumped ahead, didn't I? So that test we're going to write in a second. This test is the test that was obviously in my head, which is pulling. You can fetch. Well, let's say you can get a value. Setting a value allows us to get it later. And yeah, for the other thing, we should just say, it's like assert that this is an error, I guess. So I guess we can do assert equal environment.get missing, comma, error, and then some kind of meta. Oh, it's going to be awkward, isn't it? Well, all right. Well, we'll do this properly in a second, but for now, we're just going to assert that we're just going to get it. Oh, let's see what's happened there. We're going to get it, and then we're going to unwrap error to say this should be an error. And I guess we need to then ignore it, right? Now, get should be taking a str, not a string, and then some of our errors will shut up. And we're going to need a set, which takes a mutable reference to self, takes a name and a value, which is going to be a value. That should be called set. Pretty sure I just saved that into a file called :w. I did. All right, that's gone. Okay, so we've got a get and a set method. We've got a couple of tests. This one is still complaining because That should, we probably can just unwrap here. Can we expect error? It'd be good to explain. Yeah, it'd be good to explain what's going on here. Fetching a missing name should be an error. And while we're here, let's just to do check the error is the correct one, because we're going to want to do that. Now, environment is not mutable. So now we've got a reasonable looking test, which will hopefully fail unless something really bad's happened. A few warnings. Oh, and our original call to this staff should be passing in a reference to the symbol name, and then it will match our signature as we've now made it. Oh, and it's complaining about... Oh, well, I've somehow made the set method return something. Why is this returning a result? This kind of... I just didn't question the method that got created for us in the code that calls this, and I should have questioned it, because actually I think I should have wrapped this in an OK, and it shouldn't be returning as a result at all. Instead, it should be panicking if something goes wrong. I think so. This might be wrong. Why am I making life hard for myself by doing this? It was fine as it was. Perhaps because it's making my life hard in a second instead. So getting can be an error, but I don't think setting can actually fail. I think it's fine. I think setting just always works. Or we'll fix that later, if not. Alright, so now maybe when I run, I'll get some test failures. Yeah, so we've hit a couple of to-dos in our environment tests. And we've also still got our evaluated test failing. But one of my tests doesn't have hash test before it, so it's not running. So that was quite good to find, wasn't it? So now we should have 3 failing tests. Now let's put our evaluated test, our guiding test, back to being ignored, just briefly, so that we can have green when we've done our environment stuff. Now we should have just 2 tests failing. Yep. Okay, so let's make them pass. And actually, so far, environment is just super simple, because all you can do is get things and set things. So we're going to have some kind of map in here, which we'll call values, which is going to be a hash map of string to value, I think, which will mean that we need to bring in a hash map. Should have a capital M, I think. Yeah. And we're going to have to make one when we make an environment, and then once we've got this, once we've got this, it's going to be very straightforward. It's going to be self.values.getName dot expect missing variable. No, because I forgot that that's not what we do. We want we're turning an option into a result, and there is a way of doing it. I think it's OK or yeah. And I forget how you do miet. I guess it should be OK or else, because we're going to do clever stuff in here. It's going to be miet like that. Missing name, I guess, something like that. Expected. All right, this should be. We're returning a reference, so this should be like. Could we have a cloned method on? Okay, value doesn't have a clone. Is that really true, or am I confused in some way? Let's have a look at what value looks like. Where does value live? It does live in evaluator. Yeah, okay. It doesn't have clone, but I think it should have clone. So we've got a reference to a value inside this values map because we've looked it up in this values map. But we've got an option of a value at this point, so I can call cloned, or I could just call .clone here, I think. Does that work? No, it still need to be cloned, but I guess that's fine. It's probably a little bit better to do it last. Oh, and this should be a function. So I think, all right, I said this was simple, didn't I? Was that simple? And then this really is simple, I think, because we're just going to call values.insert name and then the value. But it's we're passing in a string, and we need to own that string that gets inserted. It says set's not used, but it's used in our tests. It'll be used in a second in real life. All right, so both of our environment tests pass, which kind of makes me think that we're not testing everything we should be. But let's add in another little bit here, which is that missing stuff is still, even when some things exist, some are still missing. So that's just to check. Like what I could have done is like made get always return anything. If you'd set anything into an environment, it would get it. We haven't actually tested that two different values are independent, so let's do that too. And we can probably squeeze that into this test too. Let's call this my other -4. And when we get it out, it's still -4. We should probably check that this test fails by setting it to -5. Running it, it's complaining about exactly that problem. Set it to -4, and we're all done. Okay, so this environment is way less complicated than we finally need to do clever stuff with scope. But for this test that we've written, it should be good enough. So let's try and remember where we were. So unignore the test again. And assume that we've got an evaluator. And we've done our leaf work. It just gets out of the environment. When we run our test, it should fail because there was a missing variable called x, and we expect there to be a variable called x, and that's because we've only done the looking it up part, which is here. We haven't done the actually setting it part here. So let's write a method called assignment, I guess, which takes in the information that we've just pulled out and does something clever. So what does it do? It takes in a symbol token and a syntax tree, which is for some reason boxed. Now, can I dredge from my memory why we ended up boxing? Let's do a quick think about that before I just give up on it. There's a lot of things here that are boxed. Oh, I guess it's because syntax tree is... I was going to say syntax tree was a trait that we needed to... But then there'd be a din there if that was... I guess it's because it's a recursive... Yeah, it's because it's a recursive data structure, right? So this is all part of syntax tree. So if assignment included a syntax tree inside it, you'd be infinitely going on. So instead it includes a pointer to a syntax tree. All right. So back to business. We've got a symbol and expression, and our job is to set that into the environment. So something like self.environment.set. And then OK. And again, an assignment... No, well, assignment will return... No, assignments don't actually return anything. But we're just, for fun, we are going to return what got assigned, I think. No, let's not. That'll be too dangerous. Let's return a 0 and add ourselves a to-do. To-do assignments should not return 0. So we're going to do the work. There's basically this code has a side effect, which is to change the environment, and then it has no return value. And the side effect is that the symbol, the name that is like stored inside this symbol, gets set in the environment with the result of evaluating this expression. And that gives us back a result, so I guess we want to question mark it. And it's a box at the moment, so I guess we want to dereference it. And this is going to definitely take a mutable reference to self because we're updating the environment. And let us just separate this stuff out to silence that borrowing error. So let's call it value. So we're going to think a little bit about what's actually going on here a sec when I've splurged out the code. But basically, we've been asked to do an assignment. We've been given the left-hand side, which is the name of the variable, and the right-hand side, which is the value that's getting stored in that name. But at the moment, what we've been given is actually just a syntax tree. We haven't evaluated it. So the first thing we need to do is evaluate the right-hand side, like do the sum or whatever it is, it's x plus 4 in our example. Get back the answer, or fail by going from this question mark. Once we've got the answer, we can then set this stuff into the environment with the name that is stored inside this symbol. And that's it. And now, is it just going to work? No, we're not actually finding the name X, which feels like... Okay, so it kind of feels like it should be working now and I've got a bug somewhere, which is exciting, isn't it? So, should we add a bit of debugging? Maybe in assignment we should print out what this symbol is. And just see whether we're anywhere close to this actually working. Okay, I don't think that did anything. I almost feel like it didn't even save. It was super quick, wasn't it? No, it just is that quick. I think. So it seems like assignment is not getting called, which is kind of surprising. So, is it because statement is not evaluating? Yeah. Okay. So this statement thing, it kind of wraps. So yeah, when the expression that we're running, let's have a look at it. The expression we're running is an assignment that is kind of wrapped up in a statement, which is this whole thing. And I, for some reason, thought that the thing you should do with a statement is absolutely nothing. So the assignment's not actually getting evaluated at all. So let's move our to-do to be right next to the thing that's wrong. And then here, I think we want self.eval tree S. Right? What is S? It's a box of a syntax tree, so it's going to be star S, just like before. And I'm going to have the question mark for if something goes wrong, we bail out. Maybe now. That's looking really hopeful. So we've printed out that debug code that we probably don't need anymore. And the final answer is pretty close to what we were looking for. So we were looking for the answer of 7, and what we've got back is an answer of 0 and then 7. And this is down to the fact that we're returning a 0 from here. Or actually, no, it's actually down to the fact that we're returning a 0 from the other place here. And the thing is, when we're evaluating a whole list of statements, we want to throw away their values when they are statements, and only return back answers when we're evaluating expressions. And this is interesting. So this iteration here, whenever it encounters a statement, it needs to keep on evaluating the next thing. Instead of just evaluating one tree, essentially, and giving it you back, it needs to evaluate multiple trees and give you back the last answer. Is that right? Yeah, but only when those trees are statements. And this all feels a bit speculative, because really we need to think about how like function bodies and stuff like that work before we can be sure that we're making sense about this. So I think what I'm going to do is add myself yet another to-do and say, actually, let's allow this weird behavior of returning a 0 and then a 7, as if that was somehow correct. And now all our tests pass, because we just hacked our tests to be totally wrong. But we put in a to-do, there should be just a 7, not 0, 7. And that's something that we'll maybe tackle next time, or maybe we'll decide that other things come first. But yeah, this thing here, this is not actually a valid Rust program. So we don't want to spend ages and ages thinking about exactly what its value is, because it's not a valid Rust program. A valid Rust program has to have like a function called main. Like I said, we don't want to waste our time figuring out exactly what it means. Although the reason why I'm hesitating is I'm wondering whether, even though it's not a valid Rust program, maybe it is a valid thing that we want to be able to run in Milk. You know, like scripting languages are different from fully compiled languages, and we're writing a scripting language, and maybe we want Milk to be able to handle, I guess these are kind of expressions, evaluating them directly and not just like programs. Or maybe also when we start evaluating the body of a function, this will trivially just work. We'll just figure this stuff out already. So, so refusing to think about that, and instead saying to you, thanks for listening. I hope you enjoyed. Now, before I go, let us just think through what we did. So, before we started, we didn't know how to deal with symbols when we were evaluating a leaf node. So we knew how, if we find a number, we knew how to turn that into a value. Like we found a number literal. We turn it into a value by just, at this point, just assuming it's an I32, and then later there'll be cleverer stuff here. But yeah, the only thing we had to do that was interesting here was error handling so far. But we hadn't handled the case of what if instead of finding a number, I found a symbol like X. And the answer is go look it up in the environment and just assume that you can always find it. But if you can't find it, it's an error, and return it. So that actually turned out to be relatively straightforward, right? Just look it up in the environment. And if we find an assignment, or a statement, if we find a statement, we just evaluate that statement and then return 0, which is the part that is dodgy. But the evaluate the statement is the right thing to do because it has presumably side effects that we want. So we just say, given this statement we've been given, just evaluate it, return any errors. And if during that evaluation process we come across an assignment, then call our new method we've written called assignment. And what that does is evaluates the right-hand side and then sets in the environment that symbol is equal to the result of evaluating that thing. By the way, I skipped over, I guess, why I split out this line into a separate line. So it was complaining, the compiler was complaining at me because I had this stuff in here, and eval tree borrows self immutably, and assignment is already borrowing self mutably, and for I guess, is this good? Is this fine? I guess this is, I was about to say maybe this is a compiler limitation, but I think it's actually correct, right? Like, unless the compiler could figure out what those two things, eval tree and assignment, actually do, the rule is if you've got something borrowed mutably, then no one else can borrow it immutably, and that I guess includes yourself in this case. So what we have to do is, but this is still happening inside. So yeah, okay, so it's not just that we're inside a method that borrows self mutably. You're allowed to borrow immutably inside a method that borrows mutably, but actually inside this statement, we were borrowing self mutably in order to do this environment.set, because set requires a mutable borrow of environment, which means that we need a mutable borrow of self. So inside the same statement, you can't both do that, borrow self mutably, and also borrow self immutably to call eval tree. So weirdly, a fix for this, I think, would be to make eval tree take a mutable reference to self. But a better fix is to just get on with the stuff we need to do that requires an immutable reference to self first, and then separate that out from where we've got a mutable reference to self. If all of that doesn't make any sense, it's not actually that important. It's just if you get an error message like I got, let me show you. Shall I show you? Let's see if I can quickly show you. If you get an error message like this, cannot borrow self as mutable more than once at a time. Second mutable borrow occurs here. Is eval tree actually? Oh, it's also borrowing mutably. Okay, so it was simpler than what I was saying. Basically, I guess it's basically the same. The both self.environment.set and self.eval tree borrow self mutably. So the compiler gets sad about that, but it's okay. In this case, it's nice and simple. We don't actually need to do those things simultaneously in some sense. We can just evaluate the tree, evaluate the expression first, and then do the environment set, and the compiler is happy. That was all a complete diversion, but the main thing is, in order to evaluate an assignment statement, because we've done all this work up front, it didn't actually look that complicated, did it? All we did was evaluate the right-hand side, set the value on the environment, and then provide the ability to look things up in the environment. So I guess the real concept here is the idea that there is an environment, and that's where X lives. So when you set X to 3, it gets put in the environment, and then when we say X in some other part of the code, it gets looked up in the environment. And environments can get much more interesting than this, but for now, they're just a place you look stuff up and set stuff. All right, anyway, hope you enjoyed, and see you next time.